going on here. There's been a lot of things on YouTube and Facebook lately about, I think it was in Amsterdam, someone was building the bridge, 3D printers on each side, and it's building the bridge over a canal as it goes. A lot of this going on the ground as well. 3D printing is a fabulous area for STEM. We do a lot of cool things at NASA, but I'm going to be very honest with you. When I go talk to my mom or my kids and I say, you should see this composite cryo tank, it's so awesome. And they're just like, okay, it's great, Mom, and thanks, and that's it. So when I go to a school and I'm like, okay, you know what, this 3D printer, we can design this kind of cool part here today, and we print it out, and they're part of that design process. You see them light up, not only from seeing that something went from their head where they're holding it in their hands, which just gives me goosebumps, but also the fact that they were provided a skill set to make that happen. And you see that pride, and I tell them, you know what you did? You just did engineering. And especially your kind of artistic students or students that don't think they're good at engineering, they're like, no, I can't do engineering, I'm not good at that. I'm like, yeah, you just did it. That's what engineering is. And so we knew this was a fabulous area. So we worked with the American Society of Mechanical Engineers and a wonderful human being named Deanne Bell. And we created the Future Engineers program. Actually a national STEM challenge that's K through 12. You don't have to have a 3D printer, you design a part. Our first challenge last year was to design a space tools. We do a younger group, kindergarten through 12 years old, and then 13 through 19. And our high school winner actually did this integrated multi-tool, and he actually put a lot of thought into this. And this will be the first student design part made in microgravity. We're actually going to print this in the printer in space. He'll be there in our Payload Operations Center when we print it, and we get to watch. Wonderful young man. The younger winner did a space planter. She's from Washington State, Sydney. She did a tour of Kennedy Space Center. She won a 3D printer for her school. The runner-ups in the older category actually got to go to LA and tour a movie production facility and see how they use 3D printing and scanning and design in the movie making process, and toured SpaceX. So we're really hoping, I mentioned how important those skills are to be designers and know how to do this. We're really hoping to grow that workforce and that skill set and get these kids excited about the aspect of designing and making, and that anyone can be a maker. I grew up in a very rural area, and so we always imagined what people in New York City or Washington, D.C. got to do that we didn't. A 3D printer kind of levels that playing field, right? I mean, you can put it in a remote country school, you can put it in an economically suppressed area, and you can do amazing things. So I encourage you to go to futureengineers.org. We just finished our second challenge. We'll be doing the next one very soon. We're always looking for mentors, and there will be lots of cool prizes, but we also have a lot of really neat tutorial videos that start from everything from Tinkercad to more complex design programs. So I'm very excited about the STEM possibilities that we have with this. We also are trying to do things like reach out to a larger design community and involve them in our process. Design optimization, how we design these parts for additive, is the key to being able to truly utilize this in a meaningful way. So GrabCAD is an online community of around 2 million designers. We did a NASA GrabCAD challenge to design a part that was traditionally manufactured, a handrail clamp assembly that we use on space station, to see how you could design that using additive manufacturing. Within 3 weeks, we had 500 entries, which was one of the largest GrabCAD challenges ever. And the beautiful part of it is, it cost NASA a total of $3,000, which means I was able to put it on a credit card purchase, which means it was a very agile, quick way to interface with a larger community outside of NASA. NASA got all the IP rights. They were very interested in working with NASA, and we were able to learn a lot about how these designers optimize that part using AEM. So we're going to do more of those, and we want to work more with those kind of communities and not keep this all in-house. The bottom line is that this is a true paradigm shift, as I mentioned. In addition to developing the technologies and the skills, we really have to get people used to the idea of using additive manufacturing in this way, and it is a different way, where it's a kind of a pioneering approach to repair and logistics. We have to be able to have access to industry and academia. Those are not buzzwords. We will not get there if we can't work with what's being developed today in these areas and just adapt them to microgravity. So please come talk to me if you're interested. I'm very creative in mechanisms and how we can interface and work together as much as possible. We have to do the foundational work. Doesn't seem as exciting as the actual 3D printer itself, but things like the characterization and the certification processes that we're designing and developing, and we're working with people on the ground are dealing with the same thing for aerospace parts, anywhere that they're trying to really institutionalize or mass produce using this capability. And ultimately, what we really want is to get a rack on space station. And that rack will become that integrated first generation fab lab, that fabrication laboratory where I can do all of these things in a one-stop shop. I can print with multi-materials and embed electronics, inspect the part, recycle, and I think that's going to be really, really cool. I think that was the last, I didn't talk as fast as I hoped. I think that was the last one, so I'm going to pause for questions.
Actually, I'm afraid we don't have any time for questions. We have to go to the next speaker. I'm sorry, but you can certainly speak.